If you're watching this video, then I'm sure that you've heard at some point in time that methylene blue is the cure-all for increased energy, increased electron transport chain function, slowing down neurodegenerative diseases, and slowing down aging. Today we're going to talk about what the science shows on that, how that works from a physiological standpoint, and whether or not methylene blue is something that we should be using or should not be using. So let's just cut right to it. Anytime I hear that there's a super supplement out there that's going to replace all the other supplements or you're going to have absolute effects on aging or energy or give you superhuman energy levels, I always become a little bit skeptical because the reality is there's no one thing that's going to fix all the problems in the world. And while, yes, methylene blue has been shown to have a lot of positive impacts on aging and antioxidant properties, on neurodegenerative conditions, on energy levels, it's not a cure-all. And today we're going to dive into kind of what that looks like. So when it comes to the energy production pathways within methylene blue, or why methylene blue can help increase energy levels, it comes down to the body's electron transport chain within the mitochondria. Now, we're not going to get super science heavy on this, but I'm sure we've all heard at some point in time that the mitochondria are the energy powerhouses of the cells. And so what that does is it's going to help us break glucose or blood sugar into ATP, which is the energy production unit within the body. That's what the body uses for all of its energy currency. It's like putting gasoline in a car. And there's a couple different phases that we go through to get from glucose into ATP or energy, right? And so one of the final two steps is the electron transport chain, which then goes into this ATP synthase enzyme. Together, we call that process oxidative phosphorylation. And so what's going to happen is within that electron transport chain, there's 4 different proteins that kind of shuttle electrons through the system there, kind of like a big production line. And that creates this hydrogen ion gradient that then we use to pump back through the gradient to create ATP. We don't have to get all the way into the science. The most important thing is to just understand kind of how methylene blue can play a role in this energy production step. So within those 4 different proteins or 4 complexes in that electron transport chain, at each one of them we're using different things and we're shuttling again those electrons through. So complex 1 within the electron transport chain uses NADH, takes the hydrogen ions and the electrons from NADH, moves them across that cellular gradient. It then uses coenzyme Q10, which is complex 2, to move those electrons into complex 4. Complex 3 comes in and uses FADH2, again pulls the electrons and hydrogen ions off of there, puts them onto that CoQ10 molecule, moves them into complex 3. Complex 3, we're going to shunt electrons again into complex 4. And along this pathway, we have a lot of kind of potential for oxidative species and traffic jams, basically. So if we think about, again, back to that analogy of a production line, right, where we've got to get from point A to point B, C, D, and finally to point E, or whatever it is, where we get the final end product. If at any point in time we get sluggish or we get slowed down or one of the factory workers decides not to show up or the conveyor belt breaks, we're going to get a slowdown in energy production. And this causes a lot of mitochondrial and cellular energy deficits. Now, from just a general health standpoint, there's a lot of health issues that can contribute to this mitochondrial energy deficit. And what happens is methylene blue will actually come in, and that has a big oxidative redox or ox redox potential within it, which means that it can grab those electrons and shunt them along the pathway. So we can bypass 1, 2, and 3 and shunt electrons directly into 4 or complex 4. Now, if we've got a conveyor belt that's not working and we're not shunting those electrons through the way that we're supposed to, and we're not creating that hydrogen ion gradient the way that we're supposed to, it's going to have big implications for our ability to produce cellular energy. It's also going to cause a lot of oxidative stress within the cells. And so the cool thing there is methylene blue, it comes in, it moves those electrons through, and it can help to prevent some of the slowdown. Now, it's not going to fix all the problems. It can't move the same number of electrons that the actual complexes themselves can move, and it doesn't take electrons from NADH and FADH2, right? So it's not going to be the same, and it's not going to be a fix. However, it can step in as kind of a short-term employee where we can, say our conveyor belt's broken, we're going to hire some temp employees to come in and at least make sure that we can still produce some of the product and everything doesn't get backed up. So this is super important. It's important to understand that while we can see some cellular energy improvements by utilizing methylene blue, it's not meant to be a long-term strategy for cellular energy and for brain health, right? So we want to make sure that if something has slowed down that conveyor belt, if we're not moving electrons through there appropriately, we're understanding why that's happening and not just taking methylene blue as a substitute to try to fix the problems, because at the end of the day, it's not going to solve all the problems. But that is kind of the mechanism and the pathway that we see within methylene blue that helps create some of that cellular energy and gives us more energy, less brain fog, all that type of things, better short-term memory. And it has been shown through research to do that. So research studies have shown that low doses over a short period of time can cause about a 7% increase in memory. So again, this is where those superhuman memory claims and things, it's tough to say that, the research has shown, and it does support some improvements in memory, but it's about a 7% improvement. And there's not been a lot of long-term safety studies that show whether or not you can do this over a long period of time. Now, methylene blue was originally created as a dye, and it was used to stain cells. And what they kind of noticed was that it has this big reduction potential and can hold on to a lot of electrons. What it's used for now from a medical standpoint in a hospital setting is a couple different things. The first one would be methemoglobinemia, where we get ferric and ferrous iron switched up on that hemoglobin molecule, which basically renders our red blood cells unable to carry oxygen. That's obviously a huge issue. And so what that does is it comes in and reduces that iron so that the hemoglobin on the red blood cells can actually hold oxygen the way that it's supposed to. The other really important thing that it is used for in a hospital setting is actually going to be for vasoplegic shock, and it can help to cause vasoconstriction to increase blood pressure in an acute situation where blood pressure has decreased, basically. Now, this is not something that we would necessarily want from a long-term standpoint. So in someone with normal blood pressure that doesn't have a vasodilation episode going on, this could potentially be an issue if we're creating vasoconstriction on the back end of that. So that's why we want to really be careful with this from a long-term use standpoint, because we don't want to be taking something every single day that causes vasoconstriction, right? So just a point of emphasis that we do want to be careful with that. There's a lot of emerging research, especially in mouse models, that methylene blue can be very helpful for the to slow down and avoid the progression of Alzheimer's and other neurodegenerative conditions. The big reason for that is the reduction and oxidation of tau proteins and beta amyloid plaquing, which of course are heavily involved in a lot of those neurodegenerative conditions. So it can slow down aging of the brain. One of the reasons that it can be very helpful for that is because of its antioxidant capacity as well. So oxidative stress in the body is what causes degeneration over time. It's kind of like an old car that has a bunch of rust on it. Because of its exposure to oxygen, it's been oxidized, and we get that rusting. So the simplest way to think about oxidation in the body is that your internal organs and everything is basically rusting. Now, obviously it's not rusting, but that's kind of what that oxidative stress looks like over time. And so methylene blue can come in as an adjuvant to help with some of that oxidation. But again, it's not the only thing that helps with that. And it's really a secondary mechanism. It just happens to have the potential to do that. There's a lot of other things we have to look at. One of them is what's causing the buildup of oxidation in the first place. If we go back to the electron transport chain, we get a release of these free electrons when we're not moving things through appropriately. So if that conveyor belt that moves those electrons through slows down, those electrons can start to leak out of those complex or protein complexes within the cell and create a lot of free radicals and reactive oxygen species. The body's really smart. The body has ways to deal with this. One of the most important ways that we deal with this is through glutathione production. The problem is if we are constantly creating these high levels of reactive oxygen species and we're not consuming enough nutrients within our diet, we are going to run out of glutathione. I just talked about this in a video with autism the other day, and how glutathione depletion is a huge thing with autism. So we want to make sure that we're not creating a lot of these free radicals. Lipid peroxides are another one of those reactive oxygen species that can create a lot of damage. Those build up within the system when we're not pushing things through. These are all things that we can actually test for on blood work and within urine, which is super cool. So we can run what's called a Nutri-Eval panel. It actually looks at all the different complexes on the electron transport chain, and it looks at kind of where we may be getting stuck throughout that process. Along the top, we see a lot of our antioxidants like glutathione, and on the bottom, we see things like lipid peroxides and 8-hydroxy-DG, which shows us what that oxidative species look like. So if you're wondering if methylene blue is something that you may want to take, we can actually look at what that entire conversion pathway from glucose into cellular energy looks like, and we can see if it's even something that you might need, because we don't want to be taking supplements that we don't need. At the end of the day, we want the body to function properly. If it's not, we want to understand why it's not and not just take something to overcome that. Now, One of the other points here of emphasis is that there's not a lot of research that has really been able to show the differences between methylene blue and some of the placebos. One of the biggest reasons is you can't really do a placebo-controlled trial here because methylene blue is in fact a dye. It will turn your urine bright blue. So you can't blind people because of that. They're going to know whether they're getting the placebo or whether they're getting methylene blue. So it kind of skews a lot of the research. So there's not a whole lot of clarity in what's going on. But in general, my recommendation with any supplement is we want to try to do the correct things from lifestyle standpoint before we start introducing supplements. Can methylene blue help in certain situations? I think the research definitely demonstrates that, but are there risks associated with it? There definitely are, specifically with hemolysis and people with G6PD deficiencies. You got issues with kidney function, issues with liver function. So we do want to be really careful with the utilization of methylene blue. And in human trials and human studies, there's not really a lot of long-term data that shows us what that safety profile kind of looks like. So my recommendation would be if you want to improve mitochondrial function and cellular energy production, the biggest thing is number one, get tested so that we can actually see exactly what's happening within that energy production pathway and all the different steps along it so we know where we need to support you appropriately. The next thing is let's make sure that we're not doing a lot of things within our lifestyle, within our diet, that are going to be damaging that electron transport pathway. So a lot of oxidative stress obviously can cause a lot of issues. So we want to make sure that we're avoiding oxidative stress. We want to make sure that we've got correct energy balance within the body and that we're not consuming too much sugar that's going to get shunted into that glucose pathway and provide excessive amounts of NADH and FADH2, which would then overload the system and overload the beginning part of that electron transport chain. We want to make sure that we've got plenty of oxygen and we're breathing appropriately and really focusing on our breath. Oxygen is the last final electron acceptor in that electron transport chain. So if we don't have enough oxygen at the end of the chain, we're not going to be able to kind of move things all the way through, and we can start to get that back up in the conveyor belt, kind of going backwards as well. A lot of toxins, a lot of drugs can have a negative impact on electron transport chain function. We don't need to get into all the drugs, but pesticides, herbicides, things like that can play a role there as well. So really making sure that we're avoiding toxic exposure within our lives. Aging is going to naturally slow down electron transport chain function as well. So doing things that just protect our aging, protect DNA senescence, things like that, super important. And then really just making sure that we're getting all of the nutrients that we need in through our diet. So big nutrients that have a big role in the electron transport chain, specifically things like B2 or riboflavin, B3 or niacin, iron and sulfur, and then coenzyme Q10, super important as well. We know about coenzyme Q10 for cardiovascular support and especially with taking statin medications, but coenzyme Q10 is the shuttle that goes from complexes 1 and 3 into 4. So super important to make sure that we've got good levels of coenzyme Q10, and then make sure that we're avoiding inflammatory stress on the body, and making sure that we don't have too much nitrous oxide, because nitrous oxide can interfere with superoxide dismutase, which is a super important antioxidant. So there's a lot of things that can go on. My recommendation would be that if you want to add in methylene blue, start slow, understand that there may be risk associated with it, and see what your tolerance is. If you have a huge improvement in memory and cognition because of taking methylene blue, I would say, if anything, number one, it's great that you found something that helps you, but number two, that's a big sign that you've got some electron transport chain and cellular respiration issues going on. And I think that warrants further research and further looking into, right? So it's great that you solved the problem in the short term, but the long-term strategy I still think needs to be like really diving into figuring out what's going on. You know, if I take methylene blue and it doesn't do anything for me, that probably means that I have healthy cellular respiration pathways and mitochondrial function. And if I'm lacking energy, I need to look elsewhere. If I take it and I feel amazing, probably a good indicator that my mitochondria aren't functioning very well, and I got to figure out why, because if I don't figure out why, we're never going to fix the body and get healthy again. So I hope this kind of helps a little bit with understanding the mechanisms of why methylene blue helps support the body. If you're interested in taking it, go for it. It's not something I'm personally going to be adding in. I've done testing. I've looked at where my mitochondrial function is. I'm supporting that in other ways. And I'd be more than happy to dive into what that testing looks like. If you comment below on this video that you want to know more about that, I'd be happy to go through that. And I'd be happy to take a look at what your testing looks like as well and help support normal mitochondrial function in your own life. So again, I hope this helps. Hope it helps you make an informed decision. Comment like below if you have comments or questions on other things you'd like to learn about. I'd always like to do that, and I always want to help support your ability to learn so you can make educated decisions for your own health. So take care.